So, welcome everyone to this our second webinar of the Chicago Booth Mobility and Cities Group. Today we're going to talk about how technology makes cities smarter. So, just before we move on with the topic, so let me just share some information about the group. So, the Chicago Booth Mobility and Cities Group was launched in 2018. We organized our first panel discussion last year in Paris, and this year, so given that the situation everyone knows, so we had decided to move online. So the group is open to alumni, students, staff, and friends of the Chicago Booth or the University of Chicago. And so you have there the LinkedIn group, so you can join us. And if you're interested, you have our contact from me, Alberto, or Zaina, who's also one of the co-presidents of the group. And we'll be organizing this webinar, so you can see down there on your there's a button for Q&A. So you have any questions? So we'll start with the presentation. I will just introduce our speaker right now, and we'll start with presentation, and then after we'll keep 15 minutes for Q&A. So just if you have any questions, just put them on the Q&A button, and we'll answer them at the end of the presentation. So, it's a pleasure to have Charlie Catlett today. So he's I have the opportunity to see one of his presentations last year in Paris, so before the lockdown, and so was one of my first candidates for having him as a speaker for this group. He's a senior research scientist at the Discovery Partners Institute at the University of Illinois. He's also senior computer science at the U.S. Department of Energy Argonne National Lab. He's also senior fellow of the Monsanto Institute at the University of Chicago. His research deals with urban data analytics, urban modeling, and the design of AI-at-the-edge computer technologies applied to urban infrastructure. Okay. He led the Array of Things project, which is going to talk about today, which is funded by National Science Foundation on urban sensing and AI at the edge, which is now part of another National Science Foundation funded effort, which is called SAGE, which is he's going also to explain today with us, which is more focused on embedding AI in environmental emergency response settings. Okay. In 2014, Charlie was recognized as one of Chicago's Tech 50 technology leaders by Crane Chicago Business, and as one of the 25 doers, dreamers, and drivers of 2016 by Government Technology magazine. He also received the Argonne Board of Governors 2019 Distinguished Performance Award, and so last but not least, he's a computer engineering graduate of the University of Illinois at Urbana-Champaign. So Charlie, welcome. I'm very happy to have you on board, and so I hand it over to you now.
Thank you, Alberto. So should I go ahead and share my screen?
Yes, go on.
Let's see, okay. Great, well, thank you for having me here, and thanks to all of you for joining us. I want to talk about this project called the Array of Things, but I want to also give you some context for why we would do a project like this, how it's going, where we started, and where we're going. And in the process, I'll also try to define some of these terms like AI at the edge or edge computing and other things. Just as a short introduction to the things that I'm doing, Alberto mentioned that I'm with the Discovery Partners Institute. This is a University of Illinois created institute that's rather new in Chicago, and it brings together partners, as you see on the left there, that include the University of Chicago and Argonne, as well as Northwestern and other universities around the world. I spent 20 years at Argonne and U Chicago, and then took a sabbatical leave to help create this new institute, where what we're trying to do is identify and create or link up with science teams that are multidisciplinary and multi-institutional to do larger projects than are typically done by, you know, 1 or 2 faculty members at a given university. Alberto mentioned that after the Array of Things, we started a new project called SAGE. And that's a project that's also funded by the National Science Foundation, as was the Array of Things. And the idea is to build a programmable platform that goes beyond what the Array of Things did to actually let end users write programs that would run inside these devices that are running in cities or in environmental sites or even in areas where there's emergency management information. So to develop a platform where the Array of Things was an instrument largely controlled by a couple of us, and so users could certainly write code that would run in the Array of Things devices or at the edge of the network. That's why we call edge computing. But it was all controlled by one group, sort of like a private instrument. And the SAGE will be cyber infrastructure that would be less like an instrument in somebody's laboratory, say a computer, and more like one that's that's offered for use across the science community. We started thinking about the Array of Things about 10 years ago as I began to look for opportunities for computer scientists and people like myself who were interested in remote sensing and data analytics. I began to look for opportunities where we could put our computational and computer science skills into making cities like Chicago work better for people. And we noticed early on, if you look at any attribute of a city, any facet of the city, whether it's, as you see here, life expectancy, health, access to healthy food, or public transit, you see that cities are collections of very different and diverse neighborhoods. And Chicago is not unique in this regard, where you know, if you look at the far left, a child that was born, you know, in the past decade, 1 mile away from the University of Chicago to the west has on average life expectancy a dozen years shorter than one born in Hyde Park or in Kenwood. And then if you look on the asthma, you can see on the south and west side some pretty significant asthma rates, more than 20% among youth there. It's tempting to look at all of these graphs and equate it with income because there is quite a correlation there, but it isn't 100%. If you look at the asthma, some of the lower income parts of the west or south sides have very good asthma, and some of the higher income places in the city, such as on the north side or in the center part of the city, have very high asthma rates. So it doesn't always correlate, but you do see that correlation. And when we thought about measuring and understanding cities across a variety of variables, including those relevant here, we had to take into account that cities are not monolithic, but they're collections of neighborhoods, and so you need to have a measurement plan that is also higher resolution than is typically done. Now, before I get into measurement and technology, the title to this talk talks about smart cities. I don't typically use that term because too often it's a shorthand for an attempt to use technology to address problems and challenges that cities have that are not really technology related and can't really be solved by technology alone, which is not to say that technology can't help. Early on in this last decade or so journey that I've been talking about, I was able to participate with the 100 Resilient Cities program, as Chicago was one of those cities. I'm pretty sure Paris was as well. And I was struck by the resilience framework, which at the time, this I think was in 2013 or 2014 or so, and I would have thought city resilience was all about infrastructure and the environment. How is the city resilient against drought or severe weather or some disruption like an earthquake or hurricane? But to be resilient, you have these other 3 quadrants as well that are not things that you typically learn about in an engineering or computer science curriculum. And so I started thinking about smart cities in a similar way to say, you know, a city really can't be smart if the people that live in that city aren't healthy, if they don't have opportunities for employment or education. A city can't really be smart if there's not a really strong strategic planning aspect to it. In the same way that you wouldn't think a person was smart just because they're wearing a, you know, smart watch, if they're not taking care of their health, if they're not thinking about opportunity, if they're not planning ahead. So I think of smart cities in here, and in this respect, what we're trying to do with the array of things really touches on all of those areas. In the bottom right with economy and society, we set out to do a project that would engage the city of Chicago at residents and community groups, and we've done a lot of work with high schools in Chicago to get kids interested in science. In the leadership and planning, we've worked very hard with the city of Chicago to design the measurement system so that they would have the information they would need for things like long-term planning. I just showed you a map of asthma across the city of Chicago, and one of the things that we measure that is of most interest to anyone that looks at the array of things is air quality. But there's also other aspects of health that we can provide data to examine, such as nighttime noise, or of course air quality, but or traffic safety that have to do with health and well-being. And then of course infrastructure and environment. We have a lot of the data that we collect that is related to transportation or other things. So we think of the array of things as a piece of technology, but that is aimed at trying to make a city like Chicago smarter in all of these different areas. And really, for our project, that boils down to having the right measurements and providing data in a way that's useful to those who want to analyze it and then act on it. In order to figure out what we would measure, I'll say back in late 2011, I first learned that the city of Chicago is going to replace 300,000 streetlights with LED lights. So when I heard that, I thought, well, they're going to roll bucket trucks out, and maybe we could put something up on the pole at the same time that they're putting something up, but I wasn't sure what we would put up. Obviously, things like weather and air quality would be useful to do. So what we did was, over the course of about 2 years, we had a half dozen workshops, most of them smaller than the group that you see here, most of them maybe 30 or 40 people, but we would bring people either from many disciplines or, in other cases, a workshop with just a single discipline or set of disciplines like transportation research scientists or social and behavioral scientists, and we had a workshop with transportation researchers. In each of these workshops, we would say, hey, we have the opportunity to put up 100 or a couple 100 devices throughout a city like Chicago for you to answer the questions you're trying to ask about the city, any city. What would those devices do? What would they measure? Would they have functions that you would want to have them do? And from those workshops, we came out with really 2 classes of measurements: the traditional ones that you see on the left that require electronic sensors, and then the ones on the right that are more difficult to do with to measure with traditional sensors. You can certainly do traffic flow by putting a sensor across the road, but you don't get a sense for the interaction between pedestrians and bicycles and vehicles. And so we call these observations because for these measurements, we needed to put a camera into the device. And because these are wirelessly connected with cellular data, we don't have unlimited data, and so we have to analyze the images within our devices because we can't send all the images back to some central place. And it turns out that architecture of doing the computing in the device or at the edge of the network, and typically it's artificial intelligence and machine learning, and so we start talking about AI at the edge. So for those kind of observations, we had to build a platform that would support being able to remotely program these devices. And at that point, the measurements are defined by the software. So we talk about things like software-defined sensors. And so these devices are open. We may decide at some point that it's very important for us to look at urban wildlife. So we can program the image processing on these devices and start to look at something that we might not have contemplated when we first put the device up. That's not the case if we decide all of a sudden now we want to measure methane. We have to physically go out with a new sensor to measure methane. So the observations are much more flexible than the traditional sensing. Now, this is what it translates into on the pole. These devices are about, 13 or 14 inches tall and wide. They're about 8 or 9 inches wide. They typically are about 20 to 24 feet, so 7 to 8 meters above the sidewalk. And that's for two reasons. One, from 0 to 3 meters is really too low. People would bump their heads on these. They might damage them with vandalism, or they may try to steal them. And the downward-facing camera that you can see in the right-hand side of the device would only be looking at people's shoes, which is good for fashion research perhaps, but not so much for what we want to try to do. And then from about 3 to 6 meters, that's where all the lights and signs are, so we couldn't put it there. So we go up above the signs and the lights, and that means there's nothing above us that's blocking the upward-facing camera where we can look at cloud cover and other things. It also means we have a very nice large field of view for that downward-facing camera, and of course there's no easy way to get to these devices if you want to try to do any sort of vandalism or theft. So here's an image of a couple of devices up on poles on the left-hand side, and our team that we work with in the Office of Electrical Operations, which is part of the Department of Transportation. The small map there in the lower left, you can see we have about 130 devices up. You can't really read that horizontal line that's there in Lake Michigan, but each of the dots along that line are 1 mile. So that line is perhaps 10 kilometers long. So what you're looking at is about 680, or about 580 square kilometers, which is the municipality of Chicago, and about 130 devices. We also have other partners that we've worked with over the past 5 years since we started putting devices up. We put the first devices up in August of 2016, but we started working with the Department of Transportation in the summer of 2014. So we've been working with them for about 6 years. But you can see there's a growing list of other groups that have put devices up for us in the city of Chicago, and some of them are international or national companies that have offered to put devices in other cities as well. JCDecaux, as you probably can guess from the name, is a French company. We work with JCDecaux North America because they operate 2,100 bus shelters in Chicago, and so they've offered to place sensors on those bus shelters for us, which we hope to take them up on sometime this summer. Now, each of the devices that you see with its several dozen sensors and cameras is sending a packet of information of a couple thousand bytes every 30 seconds. And that's every measurement from all of the sensors. It is what we pull out of images and sound. So it's most times right now we're sending back every 30 seconds a number of pedestrians that we see in our field of view from the camera image and the number of vehicles that we see. So around every 15 minutes, we also send one and sometimes more than one image back to a protected and secure database that we can use to train our edge computing, our machine learning algorithms. And so we do collect some images, but we protect them as though they were private. And although this is images in the public way, so there's no ethical or legal reason we couldn't publish all of the images, other than that we decided to go with a privacy policy that says we won't do that. because we wanted the city of Chicago, the residents, to be enthusiastic and not just accepting of the project. And so for that reason, we have a very high bar for how we protect those images. And then every 24 hours, we dump all of the new data into a download site that has been accumulating now for a couple of years. You can download all the data if you have the disk space to hold it, or you can download a month or a week's worth. And then we have an application programming interface, or API, that allows you to write applications that query the data. And for the API, we push data out every 5 minutes. So it's relatively recent data, not real time, but near real time that you can get. It's close enough to real time to be able to do some of the things that different groups that we know of are doing, like a navigation app that's looking at air quality and noise as a factor that you would use to navigate through the city. There's a University of Chicago laboratory that's run by Professor Mark Berman in psychology, and what he's got a program called Retune that right now navigates people through Hyde Park based on the naturalness of the path. And so you can say, I want to go from point A to point B, but take me along the route that's got the most nature. So it's the most quiet in terms of street noise. It's got the most trees and parks. And what Mark is doing with the Array of Things data is including some of this real-time, such as noise, whereas before he was getting a noise rating that was done using models by a particular service. So this would be more real-time, and then he wants to add air quality as well to that, I'll say, healthy navigation app. All the data is also free and open, as you saw on that slide there. And so anybody can use it for whatever purpose they would like. We publish the raw data from the sensors. We publish all of the information that you need to interpret that, including the data sheets for the sensors and other things. So let me turn to AI at the edge and what we're doing with vision. You can see, again, the picture of the node there with the processing units that are inside the blue box. There's a camera that faces the sky from the top of the blue box, and then the camera that faces down. And you can see a couple of sample images as well. In the bottom of the bottom left-hand side there, you can see the results of the object detection software that we use. And so there we're identifying people and vehicles. I'll talk in a moment about the SAGE project. This device here, we designed and set all the specifications 3 years ago. And so with the new devices that we're starting to deploy with the SAGE project, we have the advantage of the improvements in every aspect of consumer electronics, including much, much better cameras and a processing unit that is somewhere in the range of 60 to 100 times more powerful than what we have on the poles throughout Chicago today. Depending on the software that you're running, anywhere from 60 to 100 times faster. So we can do much more ambitious image processing than we have before, and I'll talk about that a little bit in relation to the COVID-19 work. Now, putting an instrument, a scientific instrument, in the public way is very different than putting it in a laboratory or even on a campus, in that people are curious about what you're doing with cameras, for example. And so early in the project, throughout the second half of 2015, we worked with experts from academia and industry and law and in other ethics, social sciences, to develop a privacy and operating policy manual for the project. We then held a workshop in early 2016, as January of 2016, with folks from outside the project, and we reviewed with them the project goals, what we were trying to do, and our governance and specifically our privacy policies. And these are, by the way, out on the project website. And then once we had the policies reviewed, there really weren't any policies out there we could draw on. In 2015, the only policy we found with that was available to the public regarding public images was that Sydney, Australia had a very good policy for how they use their surveillance cameras. And so we almost had to start from scratch. And then we went through a 6-month public comment period to the first half of 2016 and a series of public meetings where we allowed the general public to review and ask questions and make suggestions on these policies. And they asked many questions and made many suggestions, around 400 total, and that's also published along with the responses on our website. A big part of governance is oversight. It's a delicate balance because we have obligations for the project to the National Science Foundation. The City of Chicago has obligations to its residents and businesses, and so it had to be a very cooperative governance process. What you see here are I guess we're up to about a dozen or more people on the Executive Oversight Committee, and these are leaders from throughout Chicago. We collect Chief Information Officers, so we have the current and former 2 Chief Information Officers for the City of Chicago that are part of our team, and I think we'll continue that tradition with the next turnover of Chief Information Officer. We also have the President of the School of the Art Institute of Chicago. We have Dan Reed, who's a member of the National Science Board and Provost at the University of Utah, and several community organizers like Stephen Philpott and Glenn Eden. So a very good group. We meet with them usually by telephone or around a table in the city for those who want a free lunch. And we just update them on the project 3 or 4 times a year. Now, the SAGE project follows Array of Things. We learned a lot with the Array of Things about how to build a device that would survive out there in the harsh conditions of weather and dust and vibration of a city. We had to build a device because nobody built anything that had the measurements that we needed. That's a different situation today. We think that's a good thing, in that there are devices that we can use to transition from the custom devices that we created, which are manufactured for us in the Chicago area, but so we don't make them in the laboratory. So we were able to transition them to manufacturing, but nonetheless, we decided, hey, if there's product out there that can do part of what we need, then we could put something together around that. So we're looking at several commercial devices that we can build on top of, where we plug sensors in using standard interfaces. And there are a couple of options to do that with these very fast new processors. And similarly, rather than package our own low-cost cameras, we're going with higher cost but much higher quality and more reliable cameras, such as you see on the streets today, that are used for surveillance by the police or by private businesses. So as we do that, that allows us to shift our focus from making hardware that survives in the wild to hardening and documenting and expanding on the software that allows people to program these devices. Now, we originally proposed to the National Science Foundation a $20 million 4-year project to integrate all of these, what we'll call them observatories, the Array of Things in Chicago, but expanding to other cities, something called the National Ecological Observatory Network. Those blue circles are field stations that what you see on the map here are the target locations for a scaled back version of the project. NSF said, we love this idea, but instead of giving you $20 million for 4 years, we're going to give you $9 million for 2 years, and we'll let you go for 3 years so that you can work on that cyber infrastructure and expand not only to what you originally proposed, which is this diagram here with all of those sites, but to do it in such a way that allows others to join this network of measurement devices in an easy and in a easily expandable and scalable way. So we plan, and the NSF encouraged us to focus on this, the larger dots, and getting the cyber infrastructure where we need it to be, and then coming back to them. And at that point, we would probably ask for much more than $20 million. Now, who is we? The team here includes the University of Chicago. It includes DPI, where I'm now on sabbatical. It includes Northwestern University. In fact, the lead on this follow-on proposal was Pete Beckman from Northwestern, who had been my co-PI on the Array of Things project. Then we also have the NEON project participating. You can see we have several folks you may know from UChicago, including Stacy Williams, who runs our digital library efforts at UChicago, and Valerie Taylor, who's a computer scientist that is leading our education and outreach program. So SAGE is this the current focus. We started last October, and as I said, we're going to expand on what we're able to do with the Array of Things. Now, you can't really see that what I've done here is masked out the faces in this image because of our privacy policy, but I wanted to illustrate some of the things that we're looking at doing right now for COVID-19 related activities. As you may know, state of Illinois, like many other places, we were at a stay-at-home posture starting on the 21st of March. As of this week, the state is starting to open up again, but with social distancing and a recommendation that everyone wear face masks. So we started to look at how we might take images like you see here from the Array of Things and just do a new kind of image processing, one that we certainly never anticipated 5 years ago, are people wearing face masks. And so you can see in the example there, a person wearing a face mask. Not so easy to do with smaller faces, or if a person is wearing a face mask that's roughly the same color as their skin or their hair, then that's a little harder to determine. We also thought, let's see what we might be able to do in terms of measuring social distance. And at first glance, you would say, well, yeah, that'd be easy to do. You can see in the bottom center of this picture, there are 3 people walking along. They're clearly not social distancing. Then there's a group of children above them. They're clearly not social distancing. Problem is, we don't know if they're all from the same household, and so maybe it's okay that they're walking next to each other. So it's not as straightforward as one might think. We do have, we can do things like, as people are walking toward one another, do they give each other wide enough berth as they move past each other? So there are some measurements that we can do, but these are just 2 examples, face mask and social distancing, that we have begun with just to see how far we can go with the new, more powerful edge computing capabilities. Some of you may know that we've transformed the computer science department in the last 3 or 4 years at the University of Chicago. We brought in Mike Franklin from, he was the chair of computer science at UC Berkeley, which is normally rated in the top 1 or 2 in computer science. And Mike came to UChicago and has just transformed the computer science department, doubling it in size and adding emphasis on data science and systems and AI. This is a picture here, actually a couple of pictures from Mike's balcony on the 30th floor overlooking Randolph in Michigan, and you can see Millennium Park and the Pritzker Pavilion and Maggie Daley Park and Grant Park in the background. So Mike has graciously offered to allow us to host one of the new SAGE devices on his balcony, where we want to try to look at the broader picture of people interaction and vehicle interaction from much further up than 7 or 8 meters that we're up now. Now, I mentioned before, and I'll just, as I sort of wrap up here, I mentioned before that we have interest in Array of Things in multiple cities, but not necessarily doing 130 devices in every city. Rather, as part of the SAGE project, what we originally proposed was to take 4, 5, or 6 of these devices and position them in and around public places where you'd be able to compare the use of similar public venues across cities, across climates, across population size, cultures, geography, topology. And you can see on this 8 examples here, in 6 of these examples, all but Paris and New York in this slide, we already have devices in those cities, obviously in Chicago, but we have a partnership with Georgia Tech in Atlanta, with Vanderbilt in Nashville, Northern Illinois University in DeKalb, University of Bristol in the UK, and with National Chung Cheng University in Taichung City, Taiwan. And again, the idea here is to give social scientists and behavioral scientists the ability to do repeatable experiments across different cultures and across different types of cities. I mentioned Mark Berman's work already. Mark has recently gotten a new grant from the National Science Foundation, along with myself and a couple of machine learning computer vision experts from the SAGE project, to begin doing some of this work with specific social questions in mind. In this case, what does the presence or absence of public park space, how does that impact crime and other social factors? Mark's written, or his students have written, in addition to the Retune navigation app I mentioned before, they've used machine learning to analyze scenes automatically from Google Street View, or in this case from the array of things. So they analyze these scenes according to two axes. One is from natural to urban, the other is from ordered to disordered, because what they study is the effect of those two spectrums of activity and visual information on cognitive performance. So I'll close there and just to summarize, I'm at the present time working across institutions, including U Chicago and others, to look for projects like SAGE that we can spin up across our institutions. While I'm still working on SAGE with about probably a day a week of my time still doing R&D, and I'm going to try to push that back up to 6 days a week doing research like it used to be. So I'm going to close there. Maybe I'll leave the slide share in case somebody has a question about a specific slide, and I'll turn it over to Alberto.
Thank you, Charlie. It was really interesting. So I remember last time when you were in Paris, you were talking about.
I think you might be muted, Alberto.
Sorry? Can you hear me? Now, can you hear me?
Yes, we can hear you, Albert.
Okay, thanks. Now, I was thank you, Charlie, for the presentation. It's really interesting. So I remember what you showed us last year. I think we're talking more just about the rare things. But it's really interesting to see how you move forward and understanding the opportunities of use to measure and to improve quality of life, not just in cities, but across the whole countries and geography. So as we said before, if you have any questions, you can put them in the Q&A down there. So I already have some questions before I would like you to ask. So you're talking that you're working with different partners. So how do you motivate them to share the data with you? Okay, how do you work with partners?
How do we work with, what was the last word there?
With all the partners that provide you the data also. Okay. How do you work with partners? Like how do you share? How do you organize your model of data sharing with partners?
Right. So I would say all of what we've been able to do is very, very heavily dependent on building and maintaining collaborative personal relationships, and it is not. You can get a memo of agreement written and signed by two dignitaries, but as you're kind of, I think, recognizing with the question, that is just the beginning of the beginning. And so I think that there are, if I think in broad terms of a government entity, whether that's a local government or a federal government, and then another group, well, I'll say three groups: the government, researchers, scientists in universities, national laboratories, then companies that may have data, like utility companies. Mm-hmm. The value proposition for the city or for any government agency is that they get free research from the university if they can provide access to their data, because they don't have the resources or the expertise that University of Chicago, Argonne, Northwestern, University of Illinois, they don't have that expertise in-house, partly because they can't afford it just from their budget point of view, and partly because it's really sort of outside of their mission, strictly speaking. And so, you know, example of this is during COVID-19, we're working with the chief data officer from the city of Chicago who says, I need free student interns to help me analyze data, and I don't even have time to supervise them. So can you connect me with faculty members who will put students on projects working for me? So he clearly understands that giving his data, he might get some free research that he needs. Well, a university faculty member would want to do that for a couple of reasons. The first and the most important is it's an interesting problem. It's an interesting question from the point of view of their research. A close second to that would be it's an opportunity to do research that's very relevant to people, to the city of Chicago. And when we interact with faculty members, they're looking for interesting and impactful research to do. So that coupling between universities or national laboratories and local government, we have found in Chicago to be very powerful for creating it with very little friction these projects. Now, there are times when the data can't be shared with the university because it's very sensitive in one aspect or another, privacy, for example. And in those cases, there are ways to do that. In some cases, and the University of Chicago has many groups that have established formal legal agreements with, say, the Chicago public schools or with the state of Illinois, so that they can take the data, Chicago North, for example, or Chapin Hall, they can take the data and analyze it. Crime Lab is similar. They've been able to work out those agreements, but they have to keep the data and protect it for their partner. And in other cases, the data is so sensitive that we have to give the students to the agency or to the company, in the case of a utility, and say, you can make them employees and we'll guide them on the analysis that they do and talk about the results, but we, the faculty members, won't have access to your data for legal reasons. And then I sort of started to transition into industry with utilities, for example. Every state, much less every country, has different privacy rules about even something as simple as your electric bill. And so for that, you really end up, it's a combination. It starts with, can you do research that you're interested in, that's impactful, that's also of interest to the company, and if so, then you can work out these various data agreements.
Okay, thanks. There are some other questions. How do you see the barriers why that cities are having to adopt this kind of technology? Do you see any barriers coming? Do you think that the COVID is going to help speed up the transitions towards this smart city? I know you don't like the term smart city, but this putting sensors across the city and analyzing the data that is available from them?
Well, one area that we do see, and we've actually got a couple of projects that we've started and a couple of proposals that we've submitted. One area that we do see an ongoing opportunity to make cities smarter and safer is in the analysis of the sewer output of the city for infectious disease. This has been proposed over a long period of time. Argonne and Chicago and University of Illinois, Chicago and Northwestern, that team led by Argonne has for the last 7 years been working with the Metropolitan Water Reclamation District, the utility that is for the Chicago area that handles the storm and sewer water. And they, starting 7 years ago, the utility has been collecting samples at various parts of the water system to be analyzed with DNA analysis at at Argonne, and it was a result of that project they began putting antivirals into the into the sewage treatment process. We've seen around the world in other places, in Chicago and Baltimore and other places, that you can detect COVID-19 in the sewage. And so what we're working right now is to expand the number of places we have samples collected and to improve the sequencing that we do on the samples so that we can have a general purpose surveillance system that would tell us if there's an infectious disease that's starting to hit this neighborhood here or this neighborhood there. And it's something, again, that's been already contemplated for other things, including the use of narcotics.
Okay. Thanks. So you think that this is going to help develop, further develop this technology, right? Okay, there's a question from Americ Rousseau, which I think I know you know him. He's asking if you can say a few words on the O'Hare project, since this is focusing on transportation and mobility.
So I'm not able to see the question. So what's the question again?
You can say a few words on the O'Hare project.
Oh, Emmerich. Hi, Emmerich.
Yeah, Emmerich, yeah.
Oh, now I've lost the, but I don't see Emmerich's question anymore.
I don't know why it disappears. It's on the, it's, so it's a,
oh,
he's asking about.
Yeah. So thank you for bringing it up. So Emmerich is one of the leaders at Argonne National Laboratory that is looking at the use of SAGE for transportation, which I haven't really talked much about. And the plan is to deploy around O'Hare International Airport these kind of sensing devices so that we can look at the land transportation in and out, the public transit, and begin to develop computational models that would allow the city or other authorities to experiment with different policies using models before putting them into practice. So that's I would say that's one of the more ambitious uses of the technology. It will drive some of the development of SAGE as well. For example, it isn't enough to just know that there were vehicles coming in and out of the airport. We also want to know which ones are electric vehicles, which ones are ride share. Obviously, you could tell the difference between a bus and a motorcycle, but that means that we've got to do a much finer, more precise analysis of the vehicles than we would typically have been doing in just looking at for transportation congestion.
Mm-hmm. Okay, thanks. There's a question regarding what kind of collaboration is SAGE looking for at this time? So are you looking for any collaboration? What type of collaboration are you looking for?
I think our primary target right now for collaboration, where we see a lot of new collaborations coming up, is people who have ideas of how they want to do edge processing, how they want to analyze images or sound or other data, and are interested in developing code that runs in the SAGE platform. All of the software for the platform is open source and it's available. You can actually go and buy an off-the-shelf computer from Dell or a few others that you can run the software, and so you can do the development with a camera and a computer in your own office. So that's one of the primary areas of collaboration we're looking for. I would say the other one, and by the way, just on it, there are many, so there are way more things we would like to measure than we have machine learning people that can implement. So if you just look at transportation, for example, how many electric vehicles, which ones are rideshare, not rideshare? Did this vehicle come to a sudden halt in front of that bicycle because it was almost a collision? if you go from face masks to helmets, what percentage of the bicyclists are wearing helmets? What percentage of the bicyclists on public rideshare versus private bikes are wearing helmets? How often do we see bicyclists running through red lights or vehicles or pedestrians? So there's a lot that we want to do that needs this kind of expertise, and we have a finite group of people doing that. And then the second area that I was starting to mention is we are evaluating the air quality measurements and the sensors themselves that we've used over the last few years, and we're going to try to come up with a new set of sensors by the end of the summer, so that with the next version that we put out into the city of Chicago, we'll have an improved set of air quality sensors. Because as with the processors, the sensors that we chose, in the case of the gas sensors, we chose them 3, maybe 4 years ago. And then in the case of the particulate matter sensor, we chose that sensor about 1.5 years ago. So that's 2 areas of collaboration.
Okay, thanks. There's another question. I mean, you know that all mobility players collect a lot of data, like Uber, it's like bike sharing companies and so. So a question regarding how you work with them. So do you use any data from other providers, like any mobility providers, or do you think is it just you're only using your own data, and it's anyone could use it as an open source? So how do you work with those mobility providers who has a huge amount of data available? Are you using it? Are they using your data?
So we view the Array of Things project as a data provider. There are some cases where we would where it would be useful to the science community if we were to import data. An example of that is that we've been working with UChicago medical researchers for the last couple of years, and they have been evaluating air quality sensors put inside homes, and then also air quality sensors that can be put on the outside of homes. So we've coordinated with them, and they've chosen a particulate matter sensor, for example. That's the same one that we use. And so we've got a mechanism for pulling data from other sensors to mix in with our measurements, and that's a value add to the user community. When it comes to data from Uber or, the power company or any other, rideshare or what have you, that data is, to the extent that it's available, we're just a parallel data provider, so we wouldn't necessarily pull that data together with ours. That would be something that an end user might do, pull our data and then pull data from the rideshare. What we have seen is that, so the city of Chicago, so it appears that the contract that each of these companies sign with each city has different terms of access to that very sensitive data that's for competitive reasons. The city of Chicago signed their agreements with these rideshare companies requiring them to provide the data to the city, but the city's not allowed to share that data. So that's an example where if we wanted, let's say Emmerich and his team wanted to analyze Uber data, one way they could do that, of course, is work with Uber. To work through the city of Chicago, they would have to hire students and have them work as employees of the city so they could analyze the data that the city has without the city publishing the data. There is some publication of taxi data and other sorts of data from the city, but it's the precision has been removed so that it's based on neighborhood rather than exact address.
So
I'll just say about the not-profit use. Open data means open, and whether you're for-profit or not-for-profit, once we make open data open, we have no control over what you do with it. That's just the nature of, that's how open data works. So anyone can use our data, and we'd be delighted if people were able to monetize the data in some way, because that means that people are finding their use of the data helpful enough that they would pay them to use it.
Mm-hmm. Okay. So there's another question goes in this direction, like so as you said, you're not the end user of the data. So are you aware of any applications that are monetizing your data?
You know, it's been probably a good year or so since I've done any kind of close look at what's happening in Europe, but I would say there are some very good initiatives in the UK and in Europe. There are a couple of cities in the UK. London has done a fabulous job of air quality measurement across the city. Other cities like York and Newcastle and others have done similar things with air quality. What we've seen is that there are many examples where cities in Europe and elsewhere have been able to do many more sensors than the array of things, but they typically are measuring a few things. So there are cities with 20,000 temperature and humidity sensors, or that have, in the case of similar to cities like Taipei, where they have thousands of particulate matter sensors, but they're just measuring those one or two things. And that's not a good or a bad thing. It's just what we're trying to do is measure the entire context of what's happening. And when we talk to projects that are just doing air quality, we actually tell them, you don't need to buy an entire array of things device if you just want air quality. So in Europe, we tend to see projects that are more lots and lots of sensors measuring a few things, as opposed to an array of things, fewer sensors, 130, that measure lots of things.
Okay. Which are the reference cities for you in terms of measuring data? So as you said that some are just focusing on air measurement, but which are the ones that are doing the biggest job on keeping track of everything that's going on in the city right now?
Well, you know, it's sort of anecdotal, just my own familiarity. I would say among the places doing air quality, London is at the top, if not the top, of cities I've seen with respect to air quality. Some of the cities in Asia are also doing a fairly good job with air quality. Taipei, I've already mentioned. In fact, the whole island of Taiwan has about 10,000 particulate matter sensors. These are $100 devices that they've deployed in there. They're going to double that number. They also in Taiwan do a lot with flood detection using image processing. In their case, they have the network bandwidth that they can pull that data back to use high performance computing to do. I've also been impressed with the approach that they've taken in Taiwan with edge computing to look at traffic patterns, and at the same time preserving privacy, because they have very strong privacy policy there. And so some of the work that Ethan Tu has done at the AI lab there with just looking at traffic density from low-res closed circuit cameras has been quite impressive.
Mm-hmm. Great. So I think we are on time. So it was great to have you, Charlie, today. I think there's still some other questions. Can people reach out to you if they want some additional details on what you're doing? So they can reach out. You have your email address, right?
Yeah, if we're out of time, I'll just copy these questions down and provide an email response.
Okay, perfect. So as I said, thank you very much for this for your time, and thank you everyone for joining us today. So we'll keep in touch and take care. Have a nice evening or afternoon, depending where you are.